This is underwater weighing. Okay, just like with the Skinfold lab, in order to know percent body fat, we need to know body density because we'll be using the same percent fat equations. Alright, so up at the top here, we just have the basic equation for density, which is mass in grams divided by volume in milliliters. So the naturally body density would be body mass in air divided by body volume. Body mass obviously is a very easy number to get, but the whole point of underwater weighing is to measure body volume. And according to Archimedes' principle, a body immersed in water is buoyed up with a force equal to the weight of the water displaced. Okay, so we know, therefore, that the mass of the water displaced is the body mass in air minus your body mass in water. Okay, and so from the mass of the water displaced, we can use the equation for density to get the volume of water displaced. And that is equal to the mass of water displaced, which is body mass in air minus body mass in water, divided by the density of water. And we can get the density of water based on temperature. Okay, so then body volume equals the volume of water, but you need to subtract a couple of sources of air that are inside the body. One of these being residual volume, which you should have calculated for yourself by now, and you'll need to factor that in. Another one is gastrointestinal volume, which we'll have to estimate. And once you have body volume, then you can get body density, which, as I already said, is body mass in air divided by body volume. The percent fat equation that we'll be working with here is the Curie equation, but there are a number of different equations that you can find on page 290 in the lab manual. And then naturally, if you know percent fat, then you can get your fat mass by simply taking percent fat multiplied by your body mass in air. Okay, so for our example calculation, we will be using the example in the book on page 288. And we have for our subject, we have a 70 kilogram male. His body mass in water is 2.5 kilograms. His RV is 1.15 liters, and the temperature of water when we weighed him was 32 degrees Celsius. And if you look at the table on page 285 in the lab manual, you get the density of water at that temperature, which is 0.9950. Okay, so we'll start out by calculating the mass of the water displaced. And so that would be body mass in air, and we want to convert kilograms to grams, so just multiply by 1,000. So we have 70,000 grams minus the body mass in the water, which would be 2.5 kilograms times 1,000, so 2,500 grams, and that gives us 67,500 grams. Okay, and so now we can get the volume of water. By taking the mass divided by the density of water. And we have the density of water at 0.9950. Okay, so the volume of water displaced is 67,839 milliliters. All right, so now we can give body volume by taking the volume of water minus RV. Remember, you want to change volume to milliliters. So 1.15 liters divided by 1,000 is 1,000. Multiplied by 1,000 is 1,150 milliliters. And then we will estimate gastrointestinal volume at 150 milliliters. And that gives us 66,539 milliliters for body volume. So now that we know body volume, we can get body density. So we'll take body mass in air divided by body volume. Okay, and so for body density, we have 1.052 grams per milliliter. Okay, so now we can just simply plug this into the Siri equation for percent fat. And that gives us 21% body fat. And then again, you can from this you can very easily calculate fat mass and fat-free mass. So we'll take 21% of the overall body weight, or body mass. So fat mass equals 14.7 kilograms. And fat-free mass, therefore, equals 55.3 kilograms.